This little video is to show you how to make your own angle finder jig that you use with the McNaughton curved blade system, their center saver, so that you can get perfectly even thickness bowls every time. The materials you need to make the center saver angle finder jig, let me show you. The main thing you need is a piece of clear perspex, 6mm thick perspex ideally. This piece here is about 320 wide by 400, which is an ideal size, as it will mean that I can make the whole jig out of this one piece of perspex. The only other materials you will need is some small set screws. These are 5mm M5 set screws, a set of washers, ideally a wing nut and a lock nut. Tools that you will need is a good old-fashioned ruler, a nice sharp pencil or clutch pencil. You'll need a compass for making circles, as well as a large compass or something similar to make large circles with. Coloured marking pens, matching coloured tape, a coping saw for cutting out the shapes. You want a drill as well as some files to shape the pieces. You will see that the jig is actually made up out of 4 separate pieces of perspex. I'll disassemble this one so you can see each individual piece. I'll show you how to make them and reassemble them. You can see here now that I've taken the bolts out that we've got the 4 separate pieces. This is the first piece here that goes on the bottom. I'll show you how to make that piece first. Now, I've drawn out the shape for this first piece on a white piece of paper so that you can hopefully see it a little bit better in the lens. But I would suggest that if you're doing this for real, you would draw it straight out onto the paper covering the perspex. That way you can cut it out straight out of the perspex and it's done. Hopefully you can see the details here on my drawing. Basically it's just a simple case of drawing a straight line through the middle, another line at right angles. You've got 12mm holes here and here, which need to be 18.5mm centre to centre apart. You have the holes at the end of this little piece, which need to be 90 apart, and the distance from the front hole through to that centre line is 25mm. You then end up with a piece like this, where you need to physically drill out the large holes and the small holes. And then you can simply cut an outside shape to your specifications. These little curves either side here, they are used so that when it slots over the holes of the space unit, it clears the other ones on the side of the other side poles, like that. The second piece is almost exactly the same as the first piece, just without the need for the centre holes or the dishes on the side. It's purely actually used as a spacer so that you get the thickness of the whole jig to be the correct thickness. Now this next third piece here is a little bit more challenging to make, so I will draw this one as I go. I will also be showing you how to make the larger version required if you want to make the angle finder jig version 6 rather than the version 7. The benefit or the difference is that this larger version 6 basically means that you don't need to use the computer system to work out the angles. You can do so by purely aligning this on the side of the bowl and eyeballing it directly. I should mention that the version 7 is a lot faster to use and is the option I always use at this stage because it's just a lot more efficient if you do have access to a smartphone or computer to work out the angles for you, which I will explain a little bit later on. So the first thing you need to do is to draw a baseline across. Once again, you can be doing this directly on your sheet of Perspex. The second thing to do is to draw a vertical line which intersects the first line. Like so. Next, you need to mark up this line the radius of each of the blades, which I have written up for us here. So the first blade, which is the red most curved blade, has a radius of 89 millimeters. So you'll just need to find 89 and put a mark there, and then continue to do that up this line for all of these 4. So you can now see that I have marked the other 3 dimensions up that axis. The next thing you need to do is grab your compass and draw on each of the curves. Like so. You may be wondering why I'm doing 4 curves when typically there is 3 blades supplied with the medium-sized set. The 4th blade is actually from the large set that I also use. There's typically 2 blades supplied with the large set. One has the same curve as the softest curve here, but there is also another curve which sort of fits in between these 2. So I've included that so that this one jig works for both the medium and large sets perfectly well. So you'll also be able to see that, assuming I've got the dimensions right, the curve of this should match up with the curves that I have just drawn for the different blades. That being the widest one. Very good. The next step is to measure where 50 mils goes from that intersecting point at the base, where 50 mils intersects with that first curve. Just there. The next step is to see where the tangent from that point of the curve there meets up with the baseline again, which I'm marking this with a heavy pencil just so you can see it in camera, but I would suggest using a nice fine pencil so your markings are as accurate as possible for that. Just to double check, that new point that you just created on the baseline should be about 25 millimeters in from the vertical axis there. And we're going to call that point Y. The next thing you want to do is set your compass at 90 millimeters, which I have already done. And then from point Y, you'll want to just mark lightly across all of the 4 big curves. Alright, now the next thing we need to do is, once again working from point Y with the rule, you need to find where the tangent for each of these lines are, so where it just touches each of the curves, I should say, and then go and mark out here on this new line where that point is. So we're going from Y, the tangent to each of the curves, so this is the tangent of the largest curve, and then you mark where that is on that outside curve there. So that's the first one. Then once again from point Y, there's the tangent for the next curve, so I mark that out here. So these are actually the positions that we will be drilling the holes. The next one, which is not so different from the previous, is there, and the last one is right there. So if I grab this back again, what you'll find is if I lay this on here, we've basically got the tip at the intersection, Y is a centre hole, and then you've also got holes marked for each of the different coloured pieces, including another one here on the baseline. So if you are making the version 7, all you need to do once you have marked this out on an actual piece of Perspex is go along and drill out these holes that you've just marked. You want to then use either tape or coloured markers to go and mark each of the holes out, so you know which blade it relates to. Once again, the outside shape of the actual piece of Perspex isn't so critical, but if you do something similar to what I've got here, you won't go far wrong. You do also need to, I don't know if you can see it in the camera or not, engrave that baseline into the piece of Perspex as well, as we will be using that to align with the other piece that we'll get to shortly. Alternatively, if you're making the version 6, you're going to need to have a larger piece of Perspex. You'll want to go and mark off where you realistically expect the depth that you could get with each of the blades, and go and mark them on your drawing, and then have a piece of Perspex which actually incorporates that whole area. And you then want to engrave this piece with the lines, and once again colour code them so you can know what blade it is relating to. The first thing you need to do is to draw another vertical straight line, or alternatively what I'd suggest is purely just using the very edge of the Perspex itself as that straight line. You need to make it about 400 long, so I'll just mark that off there to there. You need to find a point which is 110mm up from the base, which is there, and then come in 8mm. I'll just from that point, which is right there. Matter of fact, you can actually draw that line right across your piece of Perspex. Grab your calipers, once again set to 90mm, and from that point there, mark off a curve. That will be the centre, where this piece here, where the bolts go through, will run through a groove to enable this piece to swivel around as needed. So what you'll need to do is to draw lines either side of this one, wide enough that this bolt can slide easily all the way along. Like so. Setting your compass to 110mm, which I have also done, you can also from that point go and mark off right down to the baseline at the bottom, and then most of the way here at the top, which will be where you actually cut out the Perspex itself. This long section here is what I use to get a nice straight edge, which is nice and long, to make sure that we are nice and parallel with the front face of the bowl. The width of that is not critical, so you can simply come out here and run down until you hit that point there. I've just zoomed in so you can have a closer look at what we're going to do next. Hopefully it's not going to be too hard to find a protractor, since that's something else you will also need to use. I should mention that it is important that you always use that point there, which is 8mm in from the edge line, for all of your curves through here and the next steps that we're going to use. So what you want to do is position this there on that 8mm in point, and we just want to measure off positive and negative 60 degrees from that center line here. So if we call that center line 0, we're looking at 1, 2, 3, 4, 5, 6. So that's positive 60, and then 1, 2, 3, 4, 5, 6, 60 degrees negative. And then if you just use a rule to extend that line out across there, and across there, if you then allow some area for the nut and bolt to get to here, that area through here is what you will later on cut out entirely. like this here. The next thing I would get you to do is actually go and cut out this shape, including the centre channel. You can do that on your bandsaw and a coping saw to get the inside channel cut out, because what you want to do after that, I should mention that it is good to leave the paper on both sides of the perspex at that stage still, because after you have cut it out, you then want to flip it over and do the next set of marking on the other side of the jig rather than this side. That way it is the intervals that you're about to engrave are hard against the piece underneath it, and that way you get a better accuracy for your degrees that you set. I'm not going to take the time to draw the inverse of this here, but just remember that this next lot of marking we actually want to be doing on this side of this piece. You want to put the compass down again in the same position you had it before, with the centre point there. This time you want to go and mark off every 5mm interval right through positive 60 and negative 60. Once you've done that, you then need to go and extend the points, including the 60, right through to the very edge of your perspex. Like so. Every 10 I make a bigger line, every 5 I make a smaller line. And you'll do that all the way around here. Once you've finished marking out all of these on the inverse side, you then want to take your hot poker and use it to burn straight through the paper and straight into the into the perspex on all of these lines as well. Obviously this is not going, but you get the point. Once you've finished marking them all off, both positive and negative, you then want to go back and mark through 4 short lines in between every mark, big mark, and then another 4 there. I'll just grab a pencil and show you it. And that, in effect, even though you're only doing it by eye, gives you a pretty good 1 degree interval all the way along. Extend that both positive and negative. Now the last thing you want to do before you take the paper off both sides is to go and drill out the hole there to accommodate your set screw. After that you can peel the paper off both sides of the perspex, so you have a piece which should look close to this. You then want to flip it back over so you're back working on the first side, and go through and mark out the degrees every 10 degrees. Now something I was saying incorrectly before is that you want the negative degrees going upwards on this angle and the positive going down. So using the hot poker again on this side so that the numbers are up the correct way when you read them, you want to go and mark -10, -20, and so forth, right up to -60, and this end will be +60. Now, if you've got this far, I have to say I'm impressed. The next step to do is to go and assemble each of the pieces into one complete jig. To do this, start with the first piece that we made, inserting the set screws up through it. Take the next piece that we made and slot that down on top. Like so. The next piece, once again, slots on top. This is the one that you adjust the different holes depending on what blade you're using. I'll set it on the green one at the moment, since that's the one I tend to use the most at this stage. And then the top piece slots down like so. You then want to grab a couple washers for the tops. Grab the wing nut and do him up there, and then the little tight nut you need to then just go and lightly screw down at the bottom. And there we have it, one assembled jig. Now, to use this, if you want to set it at, let's say, negative 22 degrees, that thin line that you engraved I should say, into the third piece, which is a little bit hard to see on the camera, so I've marked it with a bit of black marker here at the very end. That's the one which you keep in line to go up the scale of degrees to, in this case, negative 22. Hold it in place and just tighten up the wing nut a little bit, and that'll just stop it from slopping around. If you have any questions, please feel free to ask. If you would like to get hold of the little spreadsheet that works out the equations and details for you to use the version 7, you can email me at gavinbrunton@gmail.com and I will happily send a copy to you. Thank you for watching.